We will get started. Thank you.
Okay, good morning. Can I request the panelists to come over? Professor Gusai. Okay, can we have the presentation? Yeah, okay. All right. So, good morning, everyone. Let's start the first session of the day today. And the topic of this session is challenges in developing hydropower projects and maintaining river flows and riverbed connectivity. If you remember, the discussion on this topic actually started right yesterday itself in the first session of the meeting. So you can imagine how important this topic is and how important this session is going to be. So we have the distinguished panelists on the dais, and we will. I'll just introduce you from one side. Dr. Gusai from IIT Delhi, Bharat Jhunjhunwala, he was a professor at IIM, Dr. Onkar Bajpayee, Mr. D.P. Goel, and Mr. Anish Tay. So all of these are very distinguished people on the dais. So we'll come back to this to hear and to listen to them comments. So what I'm going to do is I'm going to start with a small presentation, which is as you have seen, this is called the setting the scene presentation, and this is more of a technical session at the moment. So what I have done is I've assembled a few slides to introduce the audience to a couple of technical terms, and then of course we'll get back to the panelists' views on that. So the discussion points for today are that is there a trade-off between the rivers and the hydropower? Second, are hydropower projects feasible if tampering with the river system is to be avoided? And can the damage to the river systems through present practice of hydropower be internalized in the project viability studies? And finally, is the proposition of minimum flows or even environmental flows without protecting river connectivity is acceptable? So these are the main discussion point which we have today. And you can see there are a lot of keywords here, for example, the environmental flows, for example, the riverbed connectivity, and so on. So I have a few slides to show you what we actually mean by them, and then the request to the panelists would be to focus on some of these discussion points. What we will do that we will start with giving 5 to 6 minutes to each of the panelists to voice their concerns and their issues on some of these specific points, and then of course we'll have the question and answer session from the moderator as well as from the audience. To start with, let's first try and understand what the environmental flow actually means. They have been defined in various ways in the literature, and this is perhaps the most comprehensive definition one can think of. And this means that it does not mean the minimum flow, which is normally the perception of the environmental flow. This means that this is a flow required for maintaining the entire ecological integrity of the river and their associated ecosystems. And it could mean a lot of things. For example, it could mean maintaining the river regime itself. It is, it means that river should be able to purify itself. It also means maintaining the aquatic biodiversity. It means recharge of the groundwater, supporting livelihoods, preventing salinity, and of course, also includes, a very important aspect which we saw yesterday, a lot of discussion on that, is to allow the river to play its role in fulfilling the cultural and spiritual needs of the people. So it's a very, very large term, very, very large and comprehensive definition of environmental flows, and we would like to hear the panelists, their views as to how to maintain the environmental flow if the hydropower projects have to be implemented. Then the next term is connectivity, and there are a lot of definitions again in the literature. The general perception, the general definition of connectivity basically means the property or degree of being connected or interconnected, which is basically an Oxford Dictionary definition. A graph theory defines it as a pair of distinct vertices which are connected through the same path. Most of us know that. But then in terms of the rivers, we typically define three kinds of connectivity. One is the geomorphic connectivity, which is the connection between the different compartments of a river. A river is very compartmentalized from the upstream catchment area to the plains and then finally to the source or sink. Then we also talk about the hydrological connectivity, which means that how is the water being transferred from upstream to downstream and also from channel to floodplain and also within the hydrological components of the system. And finally, we talk about the ecological connectivity as well, which means that how are the ecological processes and functions are connected at multiple scales. Given this, let me just go through very quickly with reference to the Ganga system. The geomorphic connectivity of a Ganga system would basically mean how the source and is connected to the sink, and in between you have a very major transfer zone which we call as the Ganga plain, for example. A typical riverscape will basically be consisting of the source and the sink, and of course in between the plains, for example. Why is it important to understand the geomorphic connectivity? Because it controls the movement of the biophysical fluxes in a very large dispersal system like the Ganga. It also shapes the operation of the geomorphic processes. It controls the distribution of the landscapes and also over a time scales of spatial as well as the temporal time scales. And moreover, it also allows you to predict, to predict the future landscape of the terrain. Similarly, hydrological connectivity can also be defined in basically three ways. One, we talk of a longitudinal connectivity, which means that how the river is connected between the upstream and the downstream part of that. Then we define the lateral connectivity, which means how the river is connected, how the river channel is connected to the adjoining floodplains. And then we also define the vertical connectivity, which means how the river is actually interacting with the groundwater systems in that region. And as you can see in a river system, the connectivity structure, particularly the dominance of the three different types of connectivity, changes quite drastically as you move from the upstream part to the downstream part. In the upstream part, in the headwaters, for example, the longitudinal connectivity is the most important, or most dominant type of the connectivity. Whereas when you come to the plains, the lateral connectivity and the vertical connectivity also becomes important. Then, of course, we can also talk about the hydrological connectivity in terms of the catchment scale and as well as the global scale. The ecological connectivity is a little bit more, complex to understand, and it generally involves all, the simple ecological connectivity is defined as I said before, the connection between the different kinds of ecological processes at multiple scales. And you can see again that you move from one part of a system to the different part of the system, the ecological connectivity and the processes and the functional zones, they actually change quite significantly. So it's very important to understand how these connectivity structures are positioned at different places or different parts of the river system, and how they are going to change if you start perturbing a part of the system, and how does that effect ultimately propagate downstream of the system. Then, of course, there are habitat connectivity, which means the habitat patches. We need to understand that all the habitats are not present in all parts of the river, and therefore they need to be also understood in terms of the connectivity and the patchiness, for example. The landscape connectivity is also talked about by the ecologists, which is very similar to what we refer as the geomorphic connectivity, but then their focus is much more on the vegetation cover or the different other different kinds of landscape elements which they consider as the part of the habitat. Now let's spend a few minutes on at least flagging the issues, the major issues which are related to the impacts of the hydropower projects on the river systems. The general perception is that the hydropower impacts the longitudinal connectivity of the system, and the other major impact is the reduced water flows downstream of the stretch. But then, if you look at the ground reality, it's much larger. The impacts are actually much larger and much wider. And you can divide them into two groups. One is the structural, impacts, which are typically the structures which are built in the river bed, as well as in the riparian zone, and also the impacts due to the operational policies of the dams and the barrages. For example, the variability of the water level, the change and the modified flow regime, the sediment dynamics, and everything else together. So if you start looking at some of these to start with, particularly in terms of the impacts, the first major impact the hydropower projects actually do on the rivers is the physical alteration of the habitats upstream of the dam, from running to it basically converts the running river to a standing water, and that obviously leads to the reduction or disappearance of the many species, or of course development of the new species, for example. It also results into a major morphological alterations downstream due to the lack of the coarser sediment which are trapped upstream of the reservoir. And then of course there are direct damage to the fauna, which is again during the sediment trapping upstream of the reservoir, and also during the flushing times. The water quality changes, because and also therefore the type of the species which are present, they also change because of the artificial connection of the different watersheds and so on. And finally, the habitat and the species alteration caused by the hydropeaking as well as the thermopeaking. Both are very important from the operational variable point of view. Now, why does it happen, and why it is important to understand the impacts of these, particularly from the point of view of impact on the ecosystem. And there are many variables which control these changes which happen in the ecosystem because of the hydropower projects. One, of course, is the size and the flow rate of the river or the tributary where the project is located. And second, the climate and habitat conditions, the type, size, and design and operation of the project, and then finally, whether there is a cumulative impact occurring because the project is located upstream or downstream of the other project. So whether there is a single hydropower project or whether there are multiple hydropower projects, for example. This is a very quick list of the changes to ecosystem and the impacts which you might perceive. Most of us panelists would know these. Reservoirs in acidification, for example, which typically occurs because of the slowing of water velocity and the slacking of the surface water, and therefore the increase in the temperature. And the colder water typically sinks, that generates desertification in the reservoir. Supersaturation is a problem because the high nitrogen levels, the nitrogen gets dissolved much and more because the water is spilling over the dams. Sedimentation is a major problem, particularly in the upstream as well as in the downstream, for example, and that leads to the problems of nitrogen, the nutrient loading upstream, and also the oxygen depletion, and of course the lack of the nutrients the downstream of the dams. The changing water levels, as I said, the hydropeaking is a major issue, again, because the water level in the reservoirs is basically governed by the demand and supply issues rather than the natural behavior of the system. And then, of course, the erosion, which is happening because of the changing water levels and the lack of the stream-side vegetation because they are all inundated at some point of time. So, but then, the question which we are trying to debate today is that are all these factors which are generally perceived as the negative impacts of the hydropower projects, are these factors, is it possible to get away with these problems? Is it possible to restore? Is it possible to mitigate at least some of these impacts and go for the hydropower? Or are there innovative ways of designing the hydropower so as not to disturb the natural behavior of the system and so on? So this is the main topic of the discussion today, and some of the points which I will put forward, first of all, is that can we, for example, design the changes in the release flow, and that is not limited to the minimum flow condition. Can we therefore change the mechanism by which the flows are released so as to mimic the natural flow of the river as much as possible? Can we adopt, for example, the correct protocols for the mobilization of the fine sediments so that the sediment supply, the nutrient supply upstream and downstream doesn't change in a very major way? And finally, can we design some structures like screens, for example, at the inlets and therefore the fish-friendly turbines, for example, or can we construct fish passes, for example? I mean, there are available. There are many structures across the country where some of these structures are available. They have, we can talk and we can debate about the functionality and